In this video, we're going to review some of the sex differences that exist in cognitive organization. You have already, ideally, watched the video that focuses on language lateralization, and now we're going to briefly talk about differences that can occur based upon sex or gender. Women tend to have larger volumes of dorsal prefrontal and associated paralimbic regions, whereas men have larger volumes of more ventral prefrontal cortex regions. So this would actually mean that the women are represented here in purple and the men are represented here in light pink. Women have increased cortical gray matter concentration in many regions of the cerebral cortex, and men gray matter concentration is more uniform across the cortex. Differences between white and gray matter between the sexes might reflect variations in cognitive organization. On average, females are better than males on short-term memory type tasks as well as verbal fluency type tasks. On the other hand, males on average are better than females on spatial relationship type tasks and on mental rotation type tasks. So why might this be so? One theory is that males might have better spatial skills because perhaps during evolution they had to tend larger territories than females so that they could hunt and bring back resources. On the other hand, females might have better language skills because during evolution, females develop good language skills to engage in social interaction. In the rearing of children, social interaction is highly, highly important. And early on, like many other species, it may have been that the women spent significantly more time with offspring than men. And this would encourage greater social interaction among women in comparison to men in the development of language skills. Females may also have been selected for fine motor skills, such as making clothes, which are related to language. Fine motor skills are also involved in the gathering component of early humanoid existence. The neural basis of these sex differences is also linked to hormones. Gonadal hormones influence the structure of neurons in the rat prefrontal cortex. So in the medial frontal cortex, neurons in male rats have larger dendritic fields. In the orbital frontal cortex, neurons in female rats have larger dendritic fields. These differences, however, are not seen when the rats have had their gonads or ovaries removed. So this suggests that particular hormones might be influencing the development of dendritic fields in men versus women. If you recall, hormones are essential for the differentiating effects of males versus females. Females are actually default in terms of testosterone needs to be received or be delivered at a particular time, and if testosterone is delivered at that particular time, then the fetus will develop as a male. If no testosterone is delivered, then the fetus will develop as a female. So hormones influence whether a fetus will develop as male or whether a fetus will develop as female. Hormones also continue to have developmental effects as animals age. Hormones continue to have developmental effects, and as hormones influence certain aspects of development that affect behavior, gender differences in behavior can also give rise to gender differences in cognitive organization. So what's interesting is that the differences in the brain that have been attributed to gender and sexuality are likely to be changing. So as gendered stereotypes change and what is considered male versus female behavior and roles, then it's highly likely that the brain regions that have in the past differentiated males and females will change and develop as well. There are also handedness differences in cognitive organization. So most right-handed people have language localized in the left hemisphere, but the opposite is not actually true for left-handed people. About 70% of left-handed individuals also have language localized in their left hemisphere, whereas about 15% have language localized in their right hemisphere, and the remaining 15% have bilateral representation of language. Anomalous speech representation is a condition in which a person's speech zones are located in the right hemisphere or in both. And prior research has found that building upon the increased communication that would need to occur between the various halves of the brain for language, Whittleson and Goldsmith found that the cross-sectional area of the corpus callosum was 11% greater in left-handed or ambidextrous individuals than individuals who were right-handed. So this could be to a greater number of fibers or thicker fibers or more myelin that is required for the continual language communication that would need to occur.